Okay, let's go over number 11 first. On my 11, let's first go ahead and anti-derive. What is antiderivative of any constant?
So,
just that x, right? And then antiderivative of our next one is going to give us x to the power of 1, oh, not 1 4, just 4. And that's going to be 1 over 4. Now, do I need plus c since when it's bounded? If I have a bound, you don't need plus c. So what I'm going to do from here is simply go ahead and say my bounds are 3 is my upper and lower is 1. And I know we used our bracket last time. Use the bracket if you want to. It does not matter. So let's plug in my 3 as my upper bound first. 2 times 3. And then we have plus 3 to the power of 4 over 4, just to make that simpler. And then when I do minus, you have to put parentheses, because that negative is going to distribute to every component after. So we have 2 times 1. And then I have plus, it's 1. So are we okay if I just write 1 over 4? Yeah. Okay. And then let's start simplifying and see what we get. 2 times 3 gives me 6. Is everyone okay with that? 3 to the power of 4 is 81, so I'm going to write 81 over 4. And then when I distribute my negative, I get a minus 2. And minus what? Minus 1 4.
Then we have 84.
Mm-hmm. So then I know these 4, the 6 minus 2 is going to go away, right? To 4. So if I take 1/4 from 80 over 4, that's going to give us plus 80 over 4. And what is 80 over 4? So our answer is 24.
Oh, okay.
So it's going to end up pretty clean. What's that? Mm-hmm. You for this one? Because you don't need U substitution. We can anti-derive this. We can't anti-derive this. When you can't anti-derive, like function in a function, then we let that inside become a U. Otherwise, you're making your life miserable. All right? We'll do more practice. Is everybody ready for number 13? Are we ready for number 13? All right. Yeah, don't worry about it. All right. So for the next one, we have 2 trig functions. I could let u equal sine or u equal cosine, but let's kind of think about it. What is a derivative of sine? Just cosine. So if I know the derivative of sine is cosine, I'm just going to let u equal sine of x. Because if I let derivative u equal cosine, I have to use negative sign. That's going to look confusing. Okay? In the end, it'll work out though. So let's go ahead and let u is going to equal sine of x. And then we're going to derive. The first one is du, because derivative of u is just 1, that I'm not going to write out. And our derivative of sine is cosine dx. And the good news is, I see cosine x dx, and I see it right there. So all I need to do is rewrite this. My sine was u substituted, so I'm going to write u. And then in place of cosine x dx, it's going to be du. And I want to go ahead and change my bound. Because if I change my bound, do I need to plug back in the x's? No. So let's go ahead and see what this number is and what this number is. So going back to pre-calc. If u is equal to sine of pi over 6. Do y'all remember the sine of pi over 6? 1/2. Anybody need me to show you this? No problem. When I draw pi over 6, that's going to give us 30, 60, 90, which is 1, root 3, and 2. And sine is opposite over hypotenuse. And it is okay to draw the tedious part. Nothing wrong with it. And then let's do sine of 0. What is sine of 0? Oh, I got you on that one. At 0, is it an opposite movement? Nope, 0. The cosine 0 is 1, though. So you are half correct. So I'm going to plug in place of pi over 6, 1/2. And in place of 0, simply another 0. So let's go ahead and derive. Is everyone ready? Good? Okay. Derivative of u is going to be u to the power 2 over 2. And because I have my bounds, I am not going to add plus c. So I'm going to go ahead and say my bounds are 1/2 and 0 to plug in. And I think I'm going to just go ahead and pull that 1/2 out right here. 1/2. And when I plug in the 1/2, I get 1/2 of squared. Does everyone see how I pulled out the bottom to the front? This 1 over 2, understood, came right out here. And then I plugged in 1 over 2 into my u. And then we have minus, and because I know my distribution is going to happen for 0, I'm going to say that's correct. And then we're looking at squared. And we know that's going to be 0 anyways. So isn't that basically 1 over 8? Yep. Because if I square the 1/2, that is 1/4 times the 1/2, the denominator multiplies basically. All right. So only difference on number 14 is the fact that I'm giving you what the x value is and the y value, so you can find the c. So if you're ready, give me a thumbs up. Okay. So the only thing that's different about number 14, I'm giving you what the x is and what the y is, which means I can find what the c is. Okay? All right, let me bring this up. When y'all can't see it, just let me know. It's hard to see what you can see and what I can see. Okay, when I see f prime, automatically write dy over dx. And I want to rewrite this as a single power, so why not bring this one up with negative 1/2? And of course, on the next step, we are going to divide it or multiply by x. So when I multiply by x, we get dy is equal to x to the negative 1/2 dx. How can I get rid of my d on the dy? You integrate on both sides. So when I integrate, we know our y is now by itself. Okay, let's do our integration rule. 1 more than 1/2 is positive 1/2 divided by 1/2. Now look at my bounds. Do I have a bound here? This is indefinite, so we have to add plus c. Let's rewrite this with the reciprocal of this to make the problem easier. Y is equal to 2x to the 1/2 plus c. Okay, if you're good with that so far, give me a thumbs up, everybody. We're all good with that number. All right, so we know I'm going to go up right here. X is 1 and y is 6. So when I plug it in, we get 6 is equal to 2 times 1 to the 1/2 plus c. What does that make my c become? 4. And at this point, all I need to do is copy this guy, but write out the c. Oh no, I should write y equals. Thumbs up. So let's go ahead and practice on the rest of them, and I'm going to record some more after I convert. So how many minutes do you think we might